1961 marked a shift. Cold War pressures fueled optics. DARPA launched the Sequoia Project. Conventional ballistics lacked sufficient speed. Light traveled at vacuum velocity. This fact changed strategic defense. Theodore Maiman achieved the pulse. Optical frequencies offered extreme energy. Standard weapons proved too slow. Early tests utilized synthetic rubies. This era prioritized rapid interception. ARPA funded various laser studies. Scientists examined photon density levels. Research teams faced high heat. Cooling systems remained very primitive. Metal targets showed thermal stress. Military leaders expected instant death. Physics dictated much slower progress. Each pulse required immense power. Capacitor banks filled entire rooms. Engineers measured the beam divergence. Atmospheric layers distorted the light. The goal remained missile defense. Interception required extreme precision levels. Optical tracking sensors were analog. Vacuum tubes controlled the timing. Oscilloscopes displayed the pulse wave. Data arrived on paper strips. Manual calculations verified the results. Secrecy shrouded the entire facility. Guards patrolled the testing grounds. Technicians wore heavy lead goggles. Safety protocols were largely experimental. The ruby rod measured centimeters. Silver mirrors focused the energy. The flash lamp ignited briefly. 1 joule of energy emerged. Efficiency stayed below 1%. Input power exceeded output significantly. Thermal management was the bottleneck. Experiments continued despite technical flaws. Audit records show high costs. Millions funded these early prototypes. The Pentagon demanded immediate results. Sputnik changed the defense landscape. Optical weapons seemed the solution. Rigid testing began in Nevada. Dust particles scattered the beam. The air absorbed the energy. Thermal blooming reduced the impact. The beam lost focus quickly. Distances remained under 1 kilometer. Intercontinental targets were unreachable then. Gravity did not affect light. This fact fascinated many generals. Straight lines simplified the math. Calculations ignored the air density. This oversight caused early failures. Corrective lenses were not invented. The hardware remained purely mechanical. Reliability stayed extremely low daily. The ruby rod was synthetic. It measured 1 centimeter thick. Chromium ions provided the gain. A helical flash lamp triggered. High voltage surged through gas. Massive capacitors stored the charge. 10,000 joules were used. Only 1 joule left optics. This hardware occupied large labs. Heavy cables linked the modules. Solid-state physics was very new. Technicians calibrated the silver mirrors. Parallel alignment determined beam quality. Small errors caused total failure. Cooling cycles took many hours. Liquid nitrogen lowered the heat. Glass housings protected the core. The light wavelength was visible. Red beams pierced the darkness. Polarization remained a major hurdle. Power supplies weighed several tons. Mobility was not yet possible. Fixed installations housed the arrays. Ground-based testing dominated the era. Vacuum seals prevented internal arcing. Spark gaps controlled the discharge. Audible cracks filled the room. Ozone smells lingered after firing. The ruby crystal absorbed heat. Internal cracking destroyed several rods. Quality control was manually done. Each rod cost many thousands. Funding covered these hardware losses. Engineers designed custom pulse circuits. Inductors shaped the electrical wave. Triggering happened within microseconds. High-speed cameras recorded the flash. Film frames captured the glow. Negative plates showed beam profiles. Distribution of energy was uneven. Hot spots damaged the targets. Focal points shifted during pulses. Mechanical vibration caused misalignment issues. Sturdy granite tables supported optics. These tables reduced ground tremors. Precision screws adjusted the pitch. Micrometer readings guided the team. Daily logs tracked every discharge. Variations occurred without clear cause. Material science struggled with loads. Synthetic rubies were quite fragile. Thermal shock broke the glass. Laboratory conditions were strictly monitored. Humidity levels affected the lamps. Dust ruined the mirror surfaces. Clean rooms were not standard. Technicians cleaned optics with silk. Alcohol removed the oily residues. Manual labor defined this period. The audit shows massive waste. Light interacts with air molecules. Photons collide with nitrogen gas. This energy heats the atmosphere. Warmer air has lower density. A thermal lens effect forms. The beam spreads outward rapidly. This phenomenon is called blooming. It limits effective weapon range. Energy density drops significantly here. Targets receive only scattered light. Metal remains cold at distance. Massive capacitor banks line the dark walls. They hum with 10,000 joules. Thick copper busbars route the current. Gray steel cabinets vibrate with internal tension. Heavy breakers snap into their active positions. High-voltage arcs dance between brass electrodes. The power cables writhe like living snakes. This energy is unstable and violent. Vacuum tubes glow with a fierce violet light. Ceramic insulators crack under the massive load. The laboratory floor shakes during the charge. Every relay is pushed to the limit. Cooling pumps struggle against the thermal surge. One single spark triggers the entire array. Puncturing steel required extreme heat. 1 kilojoule was the target. The 1961 hardware reached limits. Surface tension resisted the melt. Molten metal pooled in holes. Thermal conductivity drained the energy. Large plates acted as sinks. Thin foils burned through easily. Thick armor remained completely intact. Structural integrity stayed mostly high. DARPA analyzed the failure rates. Efficiency did not improve enough. Scaling the system proved impossible. Doubling power quadrupled the size. Weight ratios became completely absurd. A mobile laser required ships. Truck-mounted versions were too heavy. Terrain restricted the deployment options. Power cables limited the range. The recoil was non-existent here. This advantage did not matter. Lethality stayed below ballistic levels. Bullets were cheaper than light. Kinetic energy won the debate. Financial audits showed rising costs. Budget cuts hit Project Sequoia. Technical reports advised a pivot. Strategic goals shifted toward sensors. Laser rangefinding became the priority. Precise distance measurement was easier. This application used lower power. Hardware survived the transition period. Target designators replaced death rays. Modern warfare adopted this logic. Direct energy weapons were shelved. The Sequoia files were locked. Personnel moved to Project Defender. This transition happened very quickly. Laboratory space was reassigned then. Ruby rods were placed aside. Capacitors were drained for good. The final discharge was recorded. No steel was melted today. Only data points remained active. The auditor closed the file. Technical failure was the conclusion. Politics followed the physical evidence. Sequoia ended in late '61. Legacy projects inherited the data. High-energy research continued elsewhere. The audit is now complete. Project Sequoia lasted 1 year. Consumed millions in funding. The mechanical hardware reached peaks. Physical laws prevented tactical success. Atmospheric blooming killed the range. Power efficiency stayed extremely low. Weight ratios blocked any mobility. Steel targets survived most tests. The Ruby laser was weak. Direct energy weapons failed then. DARPA shifted to sensing tools. Data became the primary output. Rangefinders used the Sequoia tech. Missile defense used other means. The death ray became fiction. Physics dictated the project end. Technicians moved to new labs. The audit shows clear limits. Energy density was the bottleneck. Modern lasers owe their start. This 1961 trial proved vital. Lessons learned saved future billions. Strategic errors were not repeated. The hardware was eventually scrapped. Files remained classified for decades. We see the truth now. Light is a difficult weapon. Air is a thick barrier. Power is a heavy load. Sequoia was a necessary failure. It defined the laser age. The technical audit ends here. No further data is required. The project is officially closed.